So if you did the math, we have roughly 3 minutes per group. So this will not be a long interactive session with lots of Q&A, but there will be a break after, and so you can grab people from the relevant groups. You can,
we can tell them. That's okay.
Make this like event go on forever and talk later.
Are you sitting that one?
Yeah.
We're gonna do multiple groups, so you'll need.
Oh, then I'll go sit down.
No, you're good. You're good. You're stay. Good. Okay. So I'm gonna just start on this end. James is gonna start. You're gonna tell us what your topic was and what your deliverables were, and you get 3 minutes, and then we'll go down the line. And if you take too long, I will like come over and start dancing.
Okay, excellent. Yeah, that's right. Yeah, is the mic on? Is it on? Test, test. Good, can everyone hear me? Okay, yes, all right. So our topic was basically how could we get people to somehow pay for web services without spinning their privacy, right? So the high level topic was that when you go to a website, it's tracking all kinds of crazy stuff about you. You go to a different website, you see stuff from the old website, that seems problematic. So is there any way for users to be able to use websites in a way that hopefully keeps them free but doesn't necessarily violate their privacy? So we had a very lively discussion. I think our high-level take-home point was that probably it's very difficult to use the internet without having your privacy violated. We actually had a challenge just defining what privacy actually means, right? So we went through a bunch of different definitions for that. We also struggle with the sort of a big issue of, you know, is it sort of intrinsic to the nature of improving large-scale web services that some type of privacy has to be violated. So for example, for Google to do things like A/B tests, you know, user studies, things like that, where they improve their search and they improve their services, is it even possible for them to do that if we're not going to reveal any data to them whatsoever about the things that we do on those sites? So in a sense, we spend a lot of our time sort of just trying to wrap our minds around is it even possible to have a high-quality service like Google that would not actually track any type of user privacy? One topic that we also discussed too was possibly this impact of regulation, for example. So it may in fact be that, yes, if these companies were allowed to sort of extract as much data as they could, maybe services would get better, but we as a society might have to put some upper limit on how much private data that they can collect. In the same way that we might all love driving around our Teslas at 100 miles per hour on the highway, but clearly this would be a societal problem because most of us can't handle a high-performance car like that. So maybe there's some type of regulatory aspect that has to come in. Maybe there's also perhaps a model for people to have sort of a true privacy market where individuals actually express their desires to be tracked or not tracked at different levels, and then perhaps services could then meet those individuals, and that would perhaps allow people to sort of become more comfortable with the amount of privacy that they're revealing to these services.
Terrific. Okay, Steve, you are up.
Great. So our breakout group was considering how to bridge the gap between formal methods for security and security in the real world. We had a great dynamic discussion, lots of people from diverse backgrounds, a lot of interesting discussion, and some of the conclusions we had were that security is challenging. It is difficult, problem solved. In part because it's a whole system property. It's not one feature you add to a system, but it's actually built into the design of the system. So that's the bad news. The good news is that formal methods can provide provable security guarantees, provable up to the assumptions of the model. And moreover, this is a really exciting time for formal methods. There's a number of things coming together, increase in computing power, the infrastructure for the tools to apply these formal methods to systems, the insights and the expertise, that is, there are enough people actually becoming aware of these formal methods to actually make inroads on real systems. But nonetheless, the gap exists. There were a couple of things we thought about, ways of bridging this gap, many of them related to education. So one is educating the public that security is important, essentially creating a demand for security in products. In the same way that in many industries and in many areas, consumers demand safety in their products. Safety and security are similar in many aspects. So to create this demand for security, one promising thing is promoting fear. Making sure that people understand that there are actually problems in the system. So for example, there are some very highly visible attacks, for example, on car systems. And it comes as a great surprise to many people that people can remotely control your car, triggering the brakes and so on. It's gotten a lot of press recently and motivated a lot of people to be demanding better security. More than just fear, though, they actually need to be educated that there are solutions, that there are appropriate methodologies or promising approaches to actually building secure systems. And so these things together in the general public, knowing there is a problem, knowing that there is a solution to the problem, can hopefully create a demand for security. Also related to education is making sure that the technical people, the computer scientists that our educational institutions are producing, have the security mindset, an adversarial way of thinking about systems, so that when people are out there building systems, even if they're not security specialists, they have in mind security concerns and know how to think about the system. More than that, though, more than education of the public, education of the technical people, we identified the need perhaps for translators, people who can bridge this gap, provide the, translate technical concerns and insights to CEOs, to the lawmakers, to the policymakers. And also translating research into actual proof of concept systems. So actually instantiating them so that those proof of concept systems can lead to hopefully better penetration of real systems. And we think those translators are the kinds of people we find in the room here, people from CRCS. Strong technical skills, who are also interested in broader societal issues, and who are able to talk a number of different languages to a variety of different people. Thanks.
Right. So the topic of our group is sharing economy, and we actually kind of like merged the participants with the next topic, sharing mind, and had the discussion together. So we roughly spent about 20 minutes talking about sharing economy. So by sharing economy, so a rough definition would be the emerging platforms that allow people to share either human resources or physical resources. For example, Uber allows us to share a ride, Airbnb allow us to share our living spaces, and there are like websites that allow people to swap their local grown vegetables. So just to name a few. And I think the focus of our discussion is sharing economy really fundamentally different from traditional economy? Or is this just because we have better technologies such that we can implement, or basically we can implement how the traditional economy works better? So we have markets in traditional economy, and we're essentially having better niched market in our sharing economy at this moment. And our discussion didn't really conclude either a positive or negative answer for this, and I think it's largely an open question because on the one hand, sharing economy reaches different areas of people's life and different type of resources, such as electronic resources. But on the other hand, in the widely applied applications, for example, the online labor market, Mechanical Turkers in some countries, so MSR researchers found that like Turkers in India, for example, they find communities, they not only work on the task on their own, they actually trying to get together at different places and create environmental culture that's similar to the traditional work environment. So what defines sharing economy, and is this going to be sustainable? Should it be made to be sustainable? And if we can imagine in the future an ideal economic environment, what that will be, I think it's largely the open questions.
So in the other half of our sharing group, we talked about sharing not property, but intellectual skills, I guess, for lack of a better word. So the framing question that we used for that conversation was, could the audience of a World Cup soccer match cure cancer? And the idea behind that is I had read a newspaper article a while back when there was a World Cup soccer match, and there was something like 700 million people watched this on TV live. And that means that there was, 2.5 billion hours of human attention expended in a 3-hour window watching a bouncing ball. And the question is, what would be required to harness that attention. I mean, that's probably, I don't actually know, but that's probably more attention than was expended on the Apollo space program or the Manhattan Project, potentially. I mean, it's millions and millions of person years. And so the question was, what would you have to have in terms of systems and tools and methodologies to be able to take that attention and do something useful like curing cancer? Not that the World Cup soccer match isn't useful in its own way, but and so the deliverable that we had as something of a goal was, what would a research agenda be? What kind of questions would you have to ask, and what kind of things would you have to do to be able to make progress in that direction? And so we came up with a few things that I think are interesting. One is you have to have some notion of what are people better at than computers, because in such a system you wouldn't want people doing things that computers could do easily, and obviously, thankfully, computers can't do everything. So the first one domain is to characterize what problems fall in what area, and it was discussed that this is probably a moving target, and that in fact such a system, part of the things it might be used for would be to move that boundary, that you'd use human computing systems, and in fact there are examples of this, like Folded at Home, where people fold proteins, and they're teaching the computers how to do it better, such that eventually people won't need to do this anymore, they'll do something else, hopefully. So that was one area. Another topic was to say, what are the basic functions from which thought is composed? So for instance, on computers, if you boil it down at some level, there's a basic instruction set, and from this simple instruction set, it is possible to do everything that computers do. And a sort of working hypothesis is that there exists some basic set of cognitive functions from which people construct their thoughts, or from which a thought process could be reasonably modeled. So the question is, what are those things? Optimizing, sorting, tagging, you know, one might plausibly make a list of these things. And that could be an area of research that would involve psychology, cognitive science, math, computer science, informations and systems theory, things like that. Another topic would be, given a large problem like find a cancer drug, how do you decompose it into these smaller functions? And related to that, how do you assign tasks, appropriate tasks to appropriate resources? Learning is a key part of any thinking system, potentially. So how do you develop tasks to develop skills among the resources? And then the last category of research agenda was incentives and motivations, things like gamification and the economics of such systems. So.
Well, so far, what made our group really different, other than the fact that we were incognito under a different title, was, but also in the light of the other groups. All of the other groups that have talked to here are reaching from their disciplinary perspective into society and sort of saying the trajectory of work that I'm working on with my colleagues, where is that fitting into society? We did the opposite. We flipped it all around. We instead say, technology is changing everything. It's changing every aspect of our lives. Every value that we hold is whether or not we'll be able to hold a democratic value, an election, whether or not I'm paying a fair price, is all determined by technology. And a realization that privacy and security were kind of the first wave, but that everything in our society is up for grabs. And so if we, instead of moving from our disciplinary perspective, our group did the opposite. We said, how do we shore up society? How do we shore up government? How do we shore up civil society so that the things that they normally protect, the things that they normally look for, how do we provide them with the information or the tools that they need? And this was kind of a continuation for most of us that were there. We had started this trajectory of work this year, and has really been kind of a firestorm. We called it technology science, and we were just so busy talking about all of the amazing things that we had done. So we launched this publication forum. We got people from all these different disciplines to do really simple experiments. Primarily students are publishing, just a really interesting fact about, here's a discrimination case from Princeton Review's online pricing. Here is how ACA is not quite working because the insurance prices are going up. Here's an algorithm that will do this or that. And sort of coming from all these disciplines and just providing a scientific fact that when given to civil society and to government has had profound effects. So the articles have shown up in almost every media around the world, all major media. It's been profound. And so one of the people who was there said, well, technology science, this must have been around for years. And we said, yeah, we started in August. And so it was at that moment that we realized that we were having a conversation on a trajectory that we hadn't actually reached out to everyone else to bring on board. And this notion of technology science, this idea that in different disciplines is this quest to connect their work to society and to address the societal implication, but it's done within that disciplinary silo. It's done within that community. And what technology science does is it flips it around and gives the opportunity for the economic study to fuel the statistical study, to fuel the policy decision, to fuel a new algorithm. And it's been extremely powerful. Like I said, it started in August, and even the papers have had dramatic impact. With that paper I mentioned a minute ago on the Affordable Care Act being a statistical analysis showing that the insurance prices are going up, which is exactly what ACA was supposed to not do. CMS responded immediately by a new advisory going out to all the insurance companies, providing new grounds on which they can have to justify price increases. That's pretty profound. And it's also profound that almost all the papers are written by students. And that says that the opportunity to make that kind of impact is very low-hanging. And so we're excited about technology science. I think that the works that you're doing in your communities and in your disciplinary silos is very important, but it's also important to bring that to the real world in a way that the real world can take it as a crystallized fact and use it to shore up the things that they already do.
Great, all right, let's thank this panel.
Okay. So hello everyone. I would like to thank the participants in our group. So we had a discussion around how do we harness large-scale networks. One of the first things that actually discussed extensively is real-time analytics for large-scale networks. There appears to be a gap between theory and applications. We discussed several existing systems, large-scale graph processing systems, identified some of lack of capabilities that we'd like to have. We identified compelling applications where real-time analytics for networks would play a crucial role, such as self-driving cars, Twitter, monitoring social media, and also the financial sector, where networks are used to analyze the stock market. And the ideal framework of real-time analytics that we would like to have is algorithms that can answer queries in constant time. They require, let's say, small update times, let's say polylogarithmic in the number of vertices. They use sublinear space and also provide very good approximation guarantees. So then we discussed the notion of privacy and online social networks. So one of the things that we need to think further is how should we redesign graph algorithms by taking into account the fact that users in online social networks have certain privacy constraints. We don't have access to the whole graph. So how can we do this task efficiently? We discussed the problem of communities, a classical problem in network science, and one of the things that we realized is that it should be somehow application dependent. We were thinking about the LinkedIn graph and biological networks, and it turns out that for these two types of networks, the notion of community should take into account application-dependent characteristics. For instance, in cancer biology, you may want to find a community where the vertices not only have a good cluster structure, but also have, let's say, diversity in terms of some other attributes. And finally, we discussed the potential of network analysis in uncovering secrets, let's say, of our brain. So in particular, we discussed synaptic pruning, and in particular, how do humans are born, let's say, with a click as the brain, and after synaptic pruning, we end up with a sparser graph. How is it possible that we end up with graphs with the same number of edges, but with totally different type of connectivity properties? And can we have models that explain this kind of phenomena?
Wow, that was perfect. That was 2 minutes and 59 seconds.
We'll be quick too. So Sean Murphy's presentation was the perfect segue into our discussion, talking about identifying cohorts through I2B2 based on their clinical data that had been in their electronic health record warehouse. And so we went into that discussion thinking about the omics era. So that is when we have genomic data potentially in the clinical record, and how that changes things, how it's okay or not to use people's information for research. What makes genetic data different from their clinical data? So it's a little bit more far removed because it's only predicting a predilection for disease as opposed to actual information about a heart attack or something. And how, but the thing that makes genomic data special is that you can use it to have implications for other family members. It's not just about the person in question. The other thing that we focused on in light of that was current proposed notice of rulemaking, where there's something called the Common Rule, which you can think of as sort of HIPAA for research. And they've put out some proposed changes to it. And so we discussed the first 4 of those and how we felt about how that was going to come out. So that's what these guys are going to talk about.
We came across as being in favor of those of the rules that wanted to define informed consent a little bit more clearly and to extend informed consent to some more situations.
I was going to add to that, the idea of perhaps broadening the safe harbor rules, so there's a general order for there's a common interaction in the medical system, and then more specific approvals around as you get closer to personalized data around biopsies or disease research groups, or you have a gene that is a disease avoidance. Again, to shift the paperwork towards special cases as opposed to the whole community.
And I think we had a spirited discussion about the different issues on the common rule. Obviously, some of it needs further clarification, so we're going to start a task force on the...
Right here. He's kidding. That about sums it up.
Awesome. So let's thank this panel, and then Chris.
All right, so I had the pleasure of being with a fantastic group of students talking about the obstacles for self-driving cars. Interestingly, the first one we identified that came up was loss of employment for drivers. If you see the riots that happened in Barcelona and the tremendous resistance in France, this became not a reason not to do it, but a reality of a political obstacle that has to be overcome. But in general, just like all technologies create winners and losers, that was considered a good thing, an inevitable change that had to be managed. Liability for breakdowns in the car itself. Interestingly, I was personally surprised. The natural instinct of the group was to start looking at the car owner as the primary person liable, asking if they missed any patches, if they maintained maintenance, done trade-offs, and this is a consistent thread, is to push responsibility for a lot of the aspects onto the end user future. They believe the software providers who enable the car should have recovery methods, but they can't have zero bugs. And in fact, we need to give them strong negative feedback in terms of making sure they maintain things correctly. But there were questions about whether people want to self-provision software in cars. We talked about car companies and system integrators as being the logical locus of that, because making it all work together, generally, people want solutions, not software. And people's talked about insurance as a possibility, that we should have some blanket authority making that work. They're saying if a car gets hacked, if the owner is aware and doesn't update, again, they put a responsibility on the owner. They're talking about it could be the software engineer who didn't secure it, but there are many long-standing bugs, particularly in open source software, which don't come up. And they talked about what happened if they did physical damage. The big thing that we're talking about is whether we should have an obligation on the drivers to take over the cars in bad conditions. Are there circumstances outside the controls? And in fact, the inclination was to be conservative until we collect data and put notice and collect burden on the drivers. The big interesting question is the mix of autonomous and non-autonomous vehicles. Autonomous vehicles probably are better at foreseeing accidents, applying brakes, reacting quickly. Well, we got into a discussion about it, and the cars can learn from humans and adapt to the behavior, because they're adaptive behaviors. We got a discussion about whether humans will try to beat the algorithms. That is, if you see a car, you're heading both one way, you force the autonomous vehicle to yield to you, even if it nominally had right of way, because you know its programming is a certain way. And to try to game them in different ways, they asked about whether it should be a higher passenger license, a different kind of certification. We talked about irrational biases, and we actually talked about, can government help? There was some skepticism, but on the other hand, people talked about facilitating industry standards, obligations to update software. We did wonder what a police officer would do if they pulled over an autonomous vehicle. We talked about cities could do things to make their streets autonomously car-friendly. There are failures, characteristic ones. If the sun is right behind a red light, we have detection problems. Do we need to re-engineer these systems? The car can do some computations. Can we expect them to run a red light just the way we do? If it's, I'll pay the fine, I'm late, is this something that should be within the end user's control? And we talked about particularly challenging problems, construction and detours. We said, should it enter as a service, like by Uber's self-driving cars, so that there's no doubt that who's liable, the same way a carrier would be completely liable. They noticed it happened in other industries. The two things we didn't really talk about, non-utilitarian moral implications, because we didn't have time, and the other person said, is unified systems like this, because the attack surface or the surface is much more uniform, are they more vulnerable to catastrophic failures? And that's something we didn't actually get to discuss.
Okay, so in our panel, we talked about challenges as data science pervades everything, sort of unintended consequences, how to mitigate them, et cetera. 4 people are going to talk for about 40 seconds each. First, Sam Gassel, who used to be a senior technologist at CNN. Sam.
Hi. So one thing we've noticed is that the input to big data systems is increasingly tending to persist. We talk about the right to be forgotten. That's mostly talked about most frequently now in terms of news articles. That's what gets in the news anyway. But the right to be forgotten in terms of your individual and aggregate activity streams and data is also important, particularly as these systems are used to make long-term decisions about what outcomes various people should get. The stewardship responsibility on the part of large organizations is in fact perhaps more easily maintained by them, but the problems of opacity and control and actual proof of forgetting are important ones to address.
Okay, and now we'll turn to Ranjan Sahai, who's from Fidelity.
Yep. One of the other challenges we talked about was how to do the cost and benefit analysis of the data being used, related to the topic we had in this morning about objective function and utility function. Who defines the objective function and how it is defined? For example, big data can be used to provide individualized medicine, efficient rides, education. Who decides whether Coursera's objective is to provide free education or provide maximum number of, or acquire maximum number of users for them? So the bigger challenge we talked about is who controls the data, and really the public or the owner of the data decides about the objective function. Uber's objective function is to provide efficient ride or is to maximize their own profit. So that is what we talked about.
Okay, and now we turn to Greg Stoddard, who's a computer science PhD student. Greg?
Another issue that we spoke about is the application of bigger data and better algorithms to socially and economically important decision making, such as hiring, and how this process will inevitably reveal some unfortunate statistical realities in the United States. That, for example, education and other things about desirable employment is related to ethnicity and race and things like this. And so this will happen, and we thought that there's a need for a research agenda which can separate out sort of the computational issues from the legal and ethical issues in such a way that the computational issue can inform the discussions which will then inevitably have to be decided upon societally in the legal arena or the political arena.
And then finally, last but not least, Malavika Jairam, who is at the Berkman Center.
Hi. We talked a little bit about how with big data, it's often big data is the answer, but what is the question? And often we just don't engage with that enough. We just proceed to think the technology or the software or the platform is the answer without having a really finely grained idea of what the problem is that we're trying to solve. So we tried to look at some of the solutions that would actually optimize for things like equity, fairness, consent, knowledge, utility. And one of the sort of standard responses everyone came up with is, oh, we just need better education. And there was some pushback on that because people said, well, it's not just about making people data literate, and it's not just about making lawyers understand computer science. I would push back. I'm a lawyer, so I think computer scientists should also understand law and ethics. But I think it was also about how, with a lot of the technology that is disruptive or new or functions in startup mode, the approach is always it's better to seek forgiveness after the fact, after you've pushed boundaries of ethics or legal norms, than to ask permission up front. And we talked about how even if you wanted to ask permission, maybe the legal system just doesn't have a process for permissioning at all, or the system hasn't caught up with the technology. So we talked about how things like Uber actually just sort of create the law and the norms in some sense, and whether there are more ethical concerns that should also play into this as necessary strands in the thinking about using technology to solve problems.
Okay, all right, thank you very much.
Thank you. All right.